This is a demonstration lesson and should last about 45 minutes. If you run out of time or think you'll run out of time, you can modify the activities. The purpose of this lesson is to examine how the reading skills we have developed can help us with math, especially word problems. Our agenda for today is fairly simple. First, we're going to examine where you have been. Then, we're going to look at the Pennsylvania and Common Core standards associated with this lesson. Then we'll look at where we're going. We'll check out some word problem solving strategies, do some exercises, check in on the effectiveness of the lesson, and then let you go. You may not realize it, but all subject learning is interconnected, and all subject learning is tied to language. You may feel that math is a tough subject for you and that word problems are problematic, or you may be a math whiz. Have you helped others? Today we explore the equation word problems plus reading comprehension strategies equals success. We need to look at the Pennsylvania and Common Core learning standards because we need to know what mastery goals have been established for us. Our focus today is on how our reading skills can help when doing math. We're going to review applying appropriate comprehension strategies, using vocabulary across all academic content areas, applying appropriate strategies to analyze, interpret, and evaluate how an author unfolds an analysis or a series of ideas or events, and we'll look at how we can acquire and accurately use general academic and domain-specific words and phrases. Today we are going to look at our understanding of reading and math. We'll review reading, math, and thinking strategies. Then we'll practice some word problems and see how we do. The first question that I have for you is, what is reading? So I want to hear your answers. Now I'm going to step outside the teacher role for a second and say that at this point I would want them to think, pair, share, come up with some answers, give me some answers. We could write them on an easel pad next to the smartboard, or we could write them on a whiteboard if there's a whiteboard available, and then I would read them some definitions. Reading is the process of constructing meaning from written language. Reading is thinking. Reading is a constructive, productive, and active process of interpreting text. So again, I would ask them another question. I would ask them, what is math? And then I would have them get into partners and do think, pair, share. We could write the answers on the easel pad then or on the whiteboard, and then I would read these definitions. Mathematics is the science of patterns. The goal of mathematics teaching should be understanding concepts. Mathematics is problem solving using critical thinking and application of concepts. Students, I have this question for you. What are some ways to demonstrate understanding, interpretation, or evaluation? Then the students may give us some answers, and we could write them on the easel pad, write them on the whiteboard, and then we could go through some of these reading strategies that progress from simple to most complicated. In the beginning, reading is about phonics, decoding words, and basic vocabulary instruction. Vocabulary instruction goes with us throughout our reading progression, but this is where there's a major focus on vocabulary instruction. In the understanding process of reading, we're making connections to construct meaning. We're visualizing. We're synthesizing, summarizing, retelling. During the interpretation phase of reading progression, we're asking questions. We're not just taking in the text verbatim, accepting whatever the author has to say. We're inferring and predicting, and we're finding patterns. And during evaluation, we're determining importance, so we're actually judging a text. We're keeping track of our thinking, and we're adjusting our strategies as necessary. And then I can ask the students, How many of these actions do you think you perform when reading? And how about math? How many of these actions do you perform when you are doing math? Okay, students, here are some math strategies that I'm sure you've used at some point in your school career. The first is small group. So getting into small groups to try to figure out the problem and the answer to the problem. Manipulatives. I'm sure that you've used manipulatives, especially when you were in elementary school. You could act it out. So if you're doing a sequence of actions, you could actually physically get up, move around, and try to figure out the problem that way. You could draw a picture, make a list or a table, and after you understand the problem, you can use strategies like guess and check, work backwards, or simplify the problem. When you're using the first 5, they're the most powerful strategies. You can create your own representations. And it's through this creation that you're truly constructing meaning. Okay? How many of these strategies have you used during math instruction? And have you used any of them when you're reading? Reading and math both require deep thinking. Here are 3 thinking strategies commonly used. The first is relying on prior knowledge. So it's applying what you know to new knowledge. Okay? It's also making connections between old and new information. Then there's organizing knowledge. And that's referring to creating concepts and schemas and evaluating when to use concepts and schemas. Metacognitive strategies help you to learn in the most comfortable way possible, what is most comfortable for you, of course. Metacognition is understanding how you learn, taking ownership of your learning, and knowing when to use strategies that you'll find useful. This slide is kind of iffy. I don't know if I'm going to put this in here or not, or if I'm going to change it, but hey, it's here for now. Let's put it together. Let's look at some big ideas. Number 1, we use strategies in reading and math that are related. Number 2, the better reader you are, the better mathematician you will be. And it's unavoidable. Math and reading go together like a race and speeding. Let me tell you, students, learning one without the other is imprudent. Hopefully you guys know Frank Sinatra and you know Love and Marriage. That's why I may not put this slide in here, people. Remember, though, that writers of word problems for math do not always follow the rules of good writing. For instance, the main idea of the word problem may not be expressed in the first or second sentence. Successfully solving a complex word problem requires a close reading of the problem, talking to the text, and taking the problem slowly. Students, I want you to try this first problem by yourselves. Okay? How many ways can you make change for 50 cents? Then I would ask the students to work on that for a little while, give them paper if they need it, and I would keep a record of the time that they're spending, and then afterward we would go over the ways that they managed to solve the problem. Okay, now that we have finished our individual problem, we're going to work in groups on the next 3 problems. And I'm going to give you a bit of time for this. Once you're done, we're going to talk about the different ways that you figured out each problem and what strategy you used to figure out each problem. We're also going to try to link them back to ways that you used reading strategies to figure out a math problem. Here's a story problem for you to try in groups. This is an ancient problem. A flying goose met a flock of geese in the air and said, "Hello, 100 geese." The leader of the flock answered him, "There are not 100 of us. If there were as many of us as there are, and as many more, and half as many more, and a quarter as many more, and you, goose, also flew with us, then there would be 100 of us. How many geese were there in the flock?" Let us take a look at one more story problem. Members of the math club at Morganson Middle School sent us this problem. The math club took a field trip to see the movie An Inconvenient Truth. A total of 28 people went on the trip, including parents, teachers, and parent chaperones. There were more parents than teachers. Movie tickets cost $7, but the students got a discount and only had to pay $3 each. The group paid a total of $108 to get everyone in. Determine how many students, how many teachers, and how many parents went on the trip. How can you figure out and be certain of about how many students, teachers, and parents went on the trip? This is more of a reminder for me as to how to structure the discussion of how we solved each problem, as opposed to anything for the students. But I just wanted to include it here as an idea if you decide to use this demo lesson. When we get to this slide, we would talk about the Common Core and the Pennsylvania standards, and I would ask the students, did we address all of these standards? Where could we have done better? Where did we do well? Finally, there would be a Q&A session open to any questions whatsoever, and then I would dismiss the students.